Welcome to this NVIDIA Backend Developer interview preparation session. In this video, you will get 5 real interview questions with structured answer strategies. Follow the interviewer prompts and structure your response for strong selection outcomes.
Could you explain how you would containerize a CUDA-dependent Python service using the NVIDIA Container Toolkit within a Kubernetes environment?
To containerize a CUDA-dependent Python service, I start by using an official NVIDIA CUDA base image, which ensures the required GPU libraries are present. Then, I add Python dependencies and the service code. For Kubernetes, I leverage the NVIDIA Container Toolkit and device plugin to enable GPU access. I configure the pod spec to request GPU and set the runtime to NVIDIA. The trade-off is managing driver compatibility between the host and container, so I ensure matching versions. I also handle edge cases like GPU resource scheduling failures. This setup ensures scalable GPU accelerated service deployment.
Can you explain how you would design a job queue for GPU workloads that supports both priority scheduling and preemption? Please include key design considerations.
In designing a GPU job queue with priority scheduling and preemption, I would begin by implementing a priority queue structure that manages incoming jobs based on priority levels. Preemption is supported by allowing the scheduler to interrupt lower priority tasks, checkpoint their state, and resume later to avoid losing work. This balances responsiveness for high priority jobs while maintaining overall GPU utilization. We must handle trade-offs like potential starvation of low-priority tasks, typically mitigated by techniques like aging. Edge cases include handling very long-running tasks and ensuring efficient context switching without excessive overhead. Overall, this approach ensures fairness and efficient GPU workload management in distributed environments.
Can you explain the trade-offs between using synchronous versus asynchronous inference when handling high-throughput GPU workloads? How do these affect performance and resource utilization?
In high-throughput GPU services, synchronous inference offers straightforward execution with predictable latencies but suffers from idle GPU time during request waiting. Asynchronous inference, on the other hand, queues multiple requests concurrently, maximizing GPU utilization and throughput. However, it introduces increased system complexity and potential latency variability due to batching effects. For workloads with strict latency, SLAs, synchronous might be preferred, while asynchronous suits bursty or high volume scenarios. Edge cases include unexpected request patterns causing queue buildup in asynchronous modes. Overall, the choice depends on the balance between throughput and latency needs, plus system complexity tolerance.
Can you explain how to build a Python-based gRPC service that streams large tensor outputs efficiently for real-time inference workloads?
To build a Python gRPC service for streaming large tensor outputs, IDE implements server-side streaming RPC methods, enabling chunk transmission of tensor data using protobuf definitions tailored for tensor slices. This approach reduces memory overhead and allows real-time handling of outputs. The trade-off is slightly more complex client logic to reassemble tensor chunks. IDE also handle edge cases like dynamic tensor shapes and network dropouts by adding metadata and retry mechanisms. This design ensures efficient, scalable, and reliable inference output streaming.
Could you describe how you would design a model serving platform that automatically scales GPU pods based on the depth of the inference queue?
To design a model serving platform that auto-scales GPU pods, IDE start by continuously monitoring the inference queue depth as a key metric. When the queue depth crosses predefined thresholds, IDE trigger scale-out events to add pods and scale in when it drops below certain limits to optimize cost. This approach balances latency and resource use. The trade-off is choosing thresholds carefully to avoid oscillations. For edge cases like traffic spikes, IDE include cooldown periods and buffer capacity to maintain stability. Overall, this ensures efficient and responsive GPU utilization under varying loads.
This completes your NVIDIA Backend Developer interview preparation set. Practice these answers aloud, refine clarity, and repeat daily for stronger interview performance.